All right, so we've learned that velocity is the derivative of position, and acceleration you could either think as the second derivative of position, or you could think of it as the derivative of velocity. So when we apply that to, so the derivative of position is 3t squared over 3, which cancels to t squared. So there's our velocity equation. And from that we can create the acceleration equation, Enoch, the derivative of v. All right. So we now have three equations that are being used to describe the movement of a particle. Okay. One question we might be asked with these equations is, where is the particle at t equals 0? So in essence what this is asking is, tell me the position of 0, or tell me what is s of 0. And so you can plug 0 into your position function, and we find, well, 0 minus 0 plus 0. Our position is 0. Or maybe we want to know what is the position at time t equals 2. So we're going to figure out what is s of 2. And this might require a little bit more calculator work. So go ahead and plug and chug and generate a number for me. So when your calculator gives you the 0.6666667, it's only saying the 7 because it can't keep showing you the 6's. So it's rounded that last decimal place. We know 0.6 repeating to be the fraction 2/3. And from here, we might ask the question, what is the displacement from t equals 0 to t equals 2? Which is basically saying, from that time interval to the other time interval, how far has the particle moved? How far has it displaced? And because we found that at time 0, it was at 0, and at time 2, it was at 2/3, the displacement, in this case, is 2/3 of a unit. It's basically moved from this position to this position. So from position of 0 to position of 2/3. This, however, may not be the distance traveled, because maybe our particle moved all the way over to the right and then it came back. Or maybe it started going left and then came back to the 2/3. So displacement is a totally different question than distance traveled. And we're going to answer the question, how far did the particle travel, shortly. But for now, just displacement. Another question we might ask is, when is the velocity positive? And what that means is, when is the particle moving to the right? Because a positive velocity means moving rightward, and negative velocity means moving leftward, so in the negative direction. So in this case, our particle has the velocity equation t squared minus 6t plus 5, and we want to know, when is that equation positive? So maybe what we could do to find out where it's positive is find out where the equation equals 0, and then test some intervals. So if we set this equation equal to 0, one way of solving quadratics is the quadratic formula. Another way of solving quadratics might be by factoring, and this equation is quite nice because it does factor well for us. And we find that our velocity equals 0 at time 1, and time 5. So that gives us some time windows. We can create a sign chart where what we say is from time 0 to time 1 and from time 1 to time 5. And we're interested in whether your velocity is positive or negative in those intervals. So I could check at time 1/2 and ask myself, is my velocity positive or negative? So if I plug 1/2 into this equation, I would get a positive or negative answer. So 1/2 minus 5 is negative, 1/2 minus 1 is negative, negative times a negative is positive. And then for the interval 1 to 5, maybe I'll grab the time 2 and plug 2 into this, and I wind up getting a negative answer. So what that means is from time 0 to 1, I am moving to the right because I have positive velocity, and from time 1 to 5, I am moving to the left because I have negative velocity. If I wanted to go even further, I could test time 3 to see what's going on after 5 seconds and find that that is also positive velocity. So we have, in essence, a particle which starts and it moves first to the right for 1 second, and then it starts coming back to the left for 5 seconds, and then it moves to the right again for the rest of the time. So I kind of sketched a rough approximation of what the particle is doing. Does that make sense? With this question, we were actually able to answer lots of different questions. The first is, when is the velocity positive? Well, it's positive from time 0 to 1 and from time 5 to infinity. We can even extend this and say, when is the velocity negative? Well, it's negative from time 1 to time 5. So if we were to ask the question, what distance did the particle travel from time 0 to time 2, we can pull that information off of a couple of things that we have figured out in the last question. We know that it moved right from time 0 to time 1, so that's going to give us a distance, and also from time 1 to time 2, that's going to give us a distance. So our first time interval is our rightward displacement, and our second time interval is our leftward displacement. And those two things will give us the total distance the particle traveled. So at time 0, we already found its position was 0. We're going to need to know what is its position at time 1. And then we already found its position at time 2 to be 2/3. So the question is, what is its position at time 1? 2.3 repeating, or 7/3, 6 7/3. So that means from time 0 to time 1, it moved 7/3 of a unit to the right. And then from time 1 to time 2, it moved 5/3 of a unit to the left. So a total distance traveled would be 7/3 from time 0 to 1 plus 5/3 from time 1 to 2, which is a total distance of 12/3 or 4 units. So notice how our displacement was only 2/3, but our total distance traveled was 4 units. So the important thing is distance and displacement are not the same thing. Other things that are not the same thing, velocity is not the same thing as speed. Speed is just your magnitude, whereas velocity is direction. So velocity tells us direction and speed. So a positive velocity means we are moving to the right, and a negative velocity equals we are moving to the left. They are closely related because speed is just the absolute value of velocity. So if I said I was moving at negative 34 miles per hour, what that means is my speed is 34 miles per hour, but I am moving to the left.